Welcome to classes by Inspire Physics. Today we have the second part of the introduction of alternating current. In the last class we have seen the first part. There we have seen the integration to get a few average values of sine omega t, cos omega t, sine 2 omega t and cos 2 omega t. Now we have continuation. So here we'll start with the average value of, we see the average value of sine omega t cos omega t. Okay, in one cycle. In one full cycle, we will see the average value of a sine omega t cos omega t. Okay, we'll see that. So, how will you do this? We'll take 1 by t integral 0 to t sine omega t cos omega t. Okay, we just multiply a 2, divide and multiply a 2 here without any change in value. What is 2 sine omega t cos omega t? It is equal to sine 2 omega t. Now we can write this 1 by 2t into, 1 by 2t, integral 0 to t, so dt also there. We will write sine 2 omega t dt. Sine 2 omega t dt. Okay, now we know that the integral of sine 2 omega t dt will be 0. That we have seen yesterday. I mentioned in the last class, in the first part we have seen that. So this integral will be 0. Now what we can say, this average will be 0. Okay, so we have got the value 0. Next we will see the average value of sine square omega t in one cycle. In one cycle we see the value of sine square omega t. In the same manner we will find 1 by t integral 0 to t sine square omega t. Now, if you multiply and divide a 2, we can take 2 sine square omega t dt. What is 2 sine square theta? It is equal to 1 minus cos 2 theta. We will expand like this. So, we have 1 by 2 t into 0 to t cos 2 omega t dt. 2 sine square theta is equal to 1 minus cos 2 omega t dt. That's the expansion. 2 sine square theta is equal to 1 minus cos 2 theta. Now we need to split this. We can split in two integrals. First one is 1 into dt. Second one is minus cos 2 omega t dt. So when I split it, I have 1 by 2t common. First is 0 to t, 1 into dt. Second one is minus 1 by 2t 0 to t cos 2 omega t dt. Okay. Now what will be this value? 1 by 2t into integral dt is t. So t, we need to give the limit 0 and capital T, minus integral cos 2 omega t dt is 0. Similar to sine 2 omega t dt integral, for a full cycle this value is 0. Now this will be 0. So when you evaluate this, what will you get? 1 by 2t into, say, t, capital T, upper limit minus lower limit. T minus 0 is t, t into t, this t cancels. So 1 by 2t into t, t cancel, what will you get? You will get average value 1 by 2. So when you find average value of sine square omega t in one cycle, this will be 1 by 2. Similarly, sine omega t cos omega t, the average value will be 0. Okay. Now we are going to see the average value of alternating current in one cycle. We need to see what will be the average value. Okay. So this is our equation of alternating current. I is equal to Im sine omega t. So we will see average value of alternating current in one cycle. How will you find? So this is instantaneous current. For one cycle, I average is equal to integral I is instantaneous current dt. We need to integrate from 0 to t. To take average value, we need to divide by t. Okay, now when you substitute, we will substitute integral 1 by t. What is I? I is equal to Im sine omega t. Im sine omega t dt. Then limit is from 0 to t. Now we take Im and t outside. Im by t. Integral 0 to t sine omega t dt. Okay, and we have seen that average value sine omega t dt for a full cycle is 0. So we can take this value to be 0. This integration that we have seen in the first part of the introduction. Now, when you take the average value, we are getting a value 0 because for a full cycle, there will be a positive half cycle as well as negative half cycle. When we add the values of positive half cycle, we will get positive values. Negative half cycle values, similar negative value we will get. When we add these two, the average value will be 0. To avoid that, what we use is we take RMS value. So now we will see RMS value of AC in one cycle. Okay, how will you take RMS value? See, IRMS is equal to, we take average of I square. Okay, we take the square of current and take the average and finally take the square root. So we need to start with I square average. I square average. How will you find average? 1 by t integral. We need I square. This is I. Squaring, what will you get? Im square. Then sine square omega t dt. Okay, 0 to t. Now we need to find this. When you find this 1 by t Im square is taken outside, then integral 0 to t will take sine square omega t dt. Okay, Im square is there, 1 by t is there, 1 by t integral sine square omega t has got a value. See, we have seen here, when you take the average value of sine square omega t, 1 by t integral sine square omega t is average value. What is average value you have got? You have got 1 by 2. Okay, 1 by t also a part of that average part. Now Im square into 1 by t integral 0 to t sine square omega t. This is here, and we have got a value 1 by 2. What we can write? We can write 1 by 2. And what is the value now? Im square by 2. I square average. What is IRMS? IRMS is equal to square root of I square average. This is I square average. So take square root of this. Im square by 2. What will you get? Im by root 2. This is called RMS value of current. Similarly, we have RMS value as voltage also. We can take VRMS is equal to Vm by root 2. What is Vm? Vm is called a peak value of the alternating EMF or alternating voltage. Im is a peak value of alternating current. Okay, peak value. That's the maximum value, and this is average. This average value of RMS voltage and RMS. See, VRMS and VIRMS. They are corresponding to the DC values. Now we will see the sine values of sine pi by 2 plus omega t. That is sine 90 plus theta. That you have seen as cos theta. So I can write cos omega t. Similarly, sine 90 minus theta. Sine pi by 2 minus omega t. That also having the same result, that is cos omega t. Okay, that we need for solving a few equations related to alternating current. So this we need these two equations also. Okay, so we have seen introduction part 2 of the alternating current. We have seen RMS value of AC, very important, this one, and also the average value of AC in one cycle. Okay, thank you.